All right. Hello there. I hope you guys are doing okay. We are on to day 7, and let's go ahead and get started. So, the directions say to factor, and hopefully, when you look at this, you notice that there are 4 terms. 4 terms. So as soon as I see 4 terms, I know that I want to be factoring by grouping. So I'm going to divide those into 2 and 2, and we are going to focus on the first 2 terms and find a greatest common factor for those. All right, so I have in front a 1, and looking at my coefficients, I have 1 and 4. My greatest common factor there is going to be a 1. And then I have x to the third and x squared. So the most that I can factor out from both of them is the one with the smallest exponent. So I can factor out x times x, or x squared. So this is your greatest common factor, and we factor that out front. And then put a big parenthesis, and when I divide, 1 divided by 1 is 1. X to the third divided by x squared, we are going to subtract the exponents. Well, there we go. And that is x to the first plus 4 divided by 1 is 4. And x squared divided by x squared simplifies to be 1. So I'm looking at 1x plus 4 for those first 2 terms. All right. Then plus I'm looking at these last 2 terms. Notice it's x plus 4, and this is x plus 4. So that is, if you want to say, the common factor there, and I do need to have something out front, well, that would have to be a 1, because x plus 4 divided by 1 is x plus 4. And we can do it out kind of the longer way. You know, there's nothing there, so that would be a 1, looking at 1 and 4. But if you happen to see that the 2 terms that you have left match up with what your factor is going to be, then you can just factor that out. And so 1x divided by 1 is going to be x, and 4 divided by 1 is going to be 4, and you're going to get the same thing. Down here, hopefully you notice, yes, I do have the same factors there. That is the greatest common factor of those 2 sets of terms. So we factor that out front and say x plus 4. I would really like to see you find and put the greatest common factor out front. Doesn't have to be that big, but I really would almost prefer it that way. And what do I have left? I have the 1 times x squared, which 1 times x squared is just x squared, and the plus 1. And so here is your answer for the factorization of that 4-termed polynomial. Okay, let's take a look at number 2. So notice first it is 3 terms, and if you go through the steps, you would check first for a greatest common factor. Come on. And this a value happens to be a 1. So I'm not going to have any greatest common factor, difference of squares, which we are finally going to learn about today, and then 3 x box. But before I get into x box, let's actually write down what the a, b, and c value are. So a is equal to 1, b is equal to the coefficient of your x term, which is 4, and c is going to be your constant, which is negative 21. by writing those down, it makes finding all the values for your x very easy. So at the top, we're going to have a times c, which is 1 times negative 21, is negative 21. My b value, which goes b on the bottom, is 4. And when I multiply, I'm looking for factors of negative 21 that add to give me 4. Because this is positive, my larger factor is going to be positive. So there's only 2 sets of factors for 21. 1 and 21, 3 and 7. So the 3 and the 7 are going to be the ones that work, and it's going to be negative 3 and positive 7. So then I go into the box part, and the first term is going to be the x squared, and the last term is going to be negative 21, and the middle two are going to be the 2 that we just found multiplied by the variable, which in this case is x. So that is negative 3x and positive 7x. So as I look at the column, look at the row, I can say 1 and 7, the greatest common factor is going to be 1, x squared and x. I can factor out an x to the first. Looking at my second row, the first term is negative, so I know I'm going to factor out a negative, and I have negative 3x, negative 21. So that's going to be 3. And looking at the columns, I have 1 and a negative 3, so that also is going to be a 1. X squared and x is going to be able to factor out 1x between the two. And the last one, I have a 7, which is positive, and a negative 21, and 7 is a factor of 21. Okay, so putting this together, I have 1x minus 3 times 1x plus 7. And that is the prime factorization for that trinomial. Finally, for this spell work, we have another trinomial. And if we go through the paces, 1, we look for a greatest common factor. One of the big, quick ways that you can determine and hopefully see that there is one is that all of these coefficients and the constant are even. As soon as you see they're even, you should say to yourself, hey, I know I can divide by 2. So we divide by 2, we divide by 2, and we have x's in the first two but not in the last, so there is no common factor of x for all 3 terms. So I'm going to factor out this greatest common factor of 2, and when you divide, you you come up with a new trinomial. So 8 divided by 2, that could be 1, is 4 with an x, and 6 divided by 2 is 3. So we found the greatest common factor. We don't have a difference of squares. We do have another trinomial, so we can do the x box. And here's my x. My a is 1. My b is 4. And my c is 3. So multiplying 1 times 3, I get 3 at the top. The b is the bottom, which is 4. So factors of 3 which add up to 4 are going to be 1 and 3. 1 times 3 is 3. 1 plus 3 is 4. So looking at my newest trinomial, The first part of the trinomial goes in the first box. The last part goes in the last box. And the 2 on the diagonals multiplied by the variable you're looking at are 1x and 3x. Because when we add those two together, we get our middle b term. And final, looking at the greatest common factor for each row, 1 and 3 is going to be 1. X to the second and x, I can factor out an x. For the second row, 1 and 3 again, it is a positive. And then looking at my columns, 1 and 1 is going to be 1. X squared and x is x. And 3x and 3, this is positive, so that's going to be a positive 3 and no x here. So these are your factors, but don't forget, you factored out this 2 at the very beginning. So it definitely is a part of this trinomial. So when I put it all together, I have 2 times 1x plus 1 and 1x plus 3. And that is your prime factorization. Okay, let's jump right ahead after getting that bell work. And let's go to our notes. I really appreciate your patience with all of this. It's been quite a week. For those that don't know, my father did pass away, and my parents live in Ohio, so I've been dealing with a lot of stuff over there. But I will be back next Tuesday. So here we go. All right, so factoring a difference of squares. That is the second part that we have been talking about. It says the product of the sum and the difference of two quantities results in a difference of two squares. So the factored form of the difference of the squares is the product of the sum and the difference of the two quantities. Okay, let's take a look. You have a squared minus b squared. That is the difference. Difference means we are subtracting of two perfect squares, okay? And that is going to be equal to the square root of that first one. So if I take the square root of a squared, I'm going to get a plus the square root of the second one, which is b, times the quantity, the same square root of a, which we had here, minus the square root of b, which is here. So a difference of two squares is going to be the square root of a squared plus the square root of b squared, which is b, times quantity square root of a again, minus. So you will have two sets of parentheses. The first one will have a plus sign. The second one would have a minus sign. Here they say or this. I really would prefer you guys to use the plus sign first. So let's take a look at an example. X squared minus 9. X squared is a perfect square. It means x times x. Minus, that's the difference, of 9. 9 is a perfect square because 9 is made up of 3 times 3. So if I do the square root of x squared, that's going to be x, plus the square root of 9 is 3, times quantity, that square root of x squared again is x. Notice these are always going to be the same value, minus the square root of 9 is 3. So these first two are always going to be the same value. They'll be the square root of what the original term was. Again, you'll have the plus and the minus, and then the square root of the 9 is always going to result in the same. Another example, 4u squared minus 1, a difference of two perfect squares. So if I take the square root here and take the square root here, 4 is a perfect square. 2 times 2 gives you 4. So I have 2 here. U squared is u times u. So I have u for the second part of that square root. That gives me 2u plus square root of 1. 1 times 1 is 1. So that's where we get the 1 there. Times quantity, same thing over here, 2u minus 1. All right, so let's jump down here and do this. And I think to begin with, maybe I might write it a little bit differently, and you'll see what I mean here. So we're looking at 81v squared. 81v squared minus 64w squared. Let's rewrite this, okay? And rewrite it as, what can I take the square root of? But before I get to that, I should definitely look and go through my paces, my steps of, do I have a greatest common factor? And we've got 81v squared. So the variables are not the same. 81 is divisible by 1 and 81. It's divisible by 3 because 8 plus 1 is 9, which is divisible by 3. It's not divisible by 4, 5, 6, 7, or 8. It is divisible by 9, okay? And it's actually 9 times 9. So there's no greatest common factor is basically what I'm saying. Number 2, difference of squares. Here's the difference, and these are perfect squares. 81 can be rewritten as 9 squared, v squared, minus 64 is a perfect square. It is 8 squared, w squared, okay? So I can take the square root, and when I do that, remember, anytime you have something that is squared and you take the square root, you get just that item itself, whatever that number is. So the square root of 9 squared is 9v plus the square root of 8 squared w, since it's squared, is 8w. So that is in parentheses. And the second one is going to be 9v minus 8w. Okay? So you take and find the square root, and the square root of each of those terms becomes the first term plus the second term times quantity, first term minus the second term. Let's take a look at letter B. We have 1 minus 144q squared. So checking through my steps, do I have a greatest common factor? Well, this first one is only 1, so the only factors of 1 are 1 and 1. That's not going to work. Difference of squares? Yes, this is a difference of squares. So I can rewrite this as 1 squared, because 1 times 1 is 1, minus, and 144 is a perfect square. That is 12 times 12. And that's going to be 12 squared q squared. So when I take the square root, I'm going to get, in my first one, 1 plus 12q and quantity times 1 minus 12q. By the way, this is my favorite factoring rule. I just always have really enjoyed it. All right. And let's jump down to letter C, x squared minus 36. Check for a GCF. There's no x in the second value, so we can't factor that out, and the coefficient here is 1. I do see it is a difference of 2 squares, so I can leave this and write this back as x squared minus 36 is a perfect square. That is 6 times 6. So when I take the square root, and I do that just to remind myself, the square root of x squared is x plus square root of 6 squared, 6. And the second term is going to be x minus 6. Okay? And the last one, letter D. So we have 9x squared minus 25. GCF, there is no GCF between these. It is a difference of 2 squares. I'm going to rewrite this as 9, which is a perfect square, 3 squared x squared, minus 25 is also a perfect square, 5 squared. So taking the square root, and the square root of 3 squared is going to be 3. Square root of x squared is x, plus 5. And for the second term, 3x minus 5. So, like I said, this is my favorite kind of factoring. I know it's kind of nerdy of me, but that's okay. And that's all there is for a difference of perfect squares. So, let's turn to the next page. Just a reminder that tomorrow you are going to have a skills check. Just kind of want to see how you have been able to watch these videos and if you have been able to understand. We will do, I think, probably this page together. I'll be going through it rather quickly, and we'll do these examples, and then you will have a skills check and we'll have time to do that. Also, you do have homework number 4. It is going to be due on Tuesday. Okay? Homework number 4. Hopefully you've been working on your homework diligently and have been doing homeworks 1, 2, and 3. Make sure you get those turned into the green bin that is on the corner of my desk. Again, I do appreciate your patience through all of this. It's not something I was looking for or had hoped would happen, knew would happen at some point, but I really do appreciate your patience. All right. I hope you guys have a great day, and I will see you back with a video tomorrow. Bye-bye.